How do these things become colored? In an isolated atom, all of those d sublevel electrons have the same energy level. But when an atom is surrounded by charged ions or polar molecules, there's an electric field that is generated. And they make an unequal effect on the energies of the various d orbitals and d electrons. Meaning, kind of like the hybrid, if you remember the hybrid orbitals, sp2, sp3, when we did bonding, the level of the 3D splits. The colors have to do with the electrons being promoted and then moving back down in between these energy levels. The colors that are produced have to do with three factors: the particular element, what is the metal, the oxidation state of that element, and the kind of ligands that are bound to the element. We will talk more about this in just a little bit. So you can see the various oxidation states of nickel. So, what do we need to have colors in transitions? We need a partially filled d sublevel. Elements with completely full or completely empty are colorless. Zinc has a full d subshell. Its compounds are white. The transition metal ion, for it to exhibit color, it has to absorb light in the visible range. If the compound absorbs a particular wavelength of light, its color is the composite of those wavelengths that it does not absorb. It shows what's called the complementary color. So if light comes into this is a complex ion that we'll talk about, a copper complex ion, and it absorbs yellow and white, it's going to give off blue light. And same here, absorbing blue gives off yellow. I would have thought that that was opposite. So those d orbitals might split into two groups, just as a summary. Right? 2 orbitals at lower energy than the other 3. Light is absorbed as an electron is promoted. There's an energy gap between these two. If that energy gap corresponds to a visible light frequency, then energy is absorbed and the ion forms a colored compound. When the light passes through a compound of a transition metal, that light of the particular frequency is absorbed as an electron is promoted, and then the energy of that transition, if it occurs in that visible region, the compound is colored. And again, that's just kind of restating. So that difference in energy level depends on the nuclear charge and identity of the metal ion, charge density of the ligand, the number of d electrons present, and the shape of the complex ion.